Good morning, everyone. This is our last week of instruction. Next week, we have the third exam. I'll post something about the exam later today. But I can tell you it would be somewhat like the second exam in structure. It will have maybe a dozen or so multiple choice kind of questions, then maybe half a dozen programming questions. And the focus of the questions will be on functions and nested loops, and the topic that we are covering this week, which is lists. Of course, there will be an expectation that you know how to construct if statements and assignments, expressions, conditions, do loops, etc. Because without that, you cannot do much programming. So I will post something later this day, by afternoon or so, about the exam. So look for it under the exams folder. And what I want to talk about is the lab a little bit, and then we will move on to the class exercise like all days. So let me talk about what the lab is all about. In the lab, you will download not a Word file, but a zip file from the D12 site. It is called the lab12.zip. And when you download it, you get two documents. Let me share one of those documents with you to start with. So this is the Word document. And here are the instructions. Download the file, then unzip it, and you will get a file called lab12starter.py. I will show you that file in a few minutes. You need to make some changes there and then execute that program. It's a long program, but you need to just modify or actually add basically 3 lines of code. I'll tell you what that is in a minute. And then you will execute that, make sure that the program is working, and then you will do some more executions, and you will copy the results of that execution into a D12 quiz. You need to also copy the code that you created into the D12 quiz. You don't submit any Python file this week. You just do the quiz. The quiz has a few questions, multiple choice questions, and there are a few places where you need to copy some stuff from your idle windows, from the program as well as from the executions. Now let me start about what that program is all about. This program compares binary search and sequential search, which you have read in reading 7. And I will show you the Python file in a few minutes, but before that, I want to show you what the executions look like, and then say a few words about sequential search and binary search. So when you run the program, it will ask for a list size. This is the number of elements in a list that you are employing to search. And you are going, in this case, I give 10,000 as the beginning list size. And I'm going to increase the list size and see how the program behaves in increments of 1,000 each. So I'm starting at a list size of 10,000. then create a list size that is 11,000, then 12,000, etc., all the way through 20,000. So I am going to see how binary search and sequential search would perform for various list sizes. So I'm going to create a list of size 10,000. You don't have to worry about how that list is created. I'm creating it. Your task is relatively simple, just writing 3 lines of code, essentially. So don't worry too much about how that list is created or anything. I will give you some ideas, but you don't have to know. Okay. And when I am testing with sequential search, I am asking the program to do 100 searches for each list size. But with binary search, I am asking the program to do 1,000 searches for each list size. The reason is sequential search is a little slower than binary search. In fact, much slower for large lists. So I need to iterate many, many times for binary search in order to get some meaningful values. Otherwise, the overhead of starting a function, setting up the search itself will be too much. So to not skew the results, I am running each search algorithms many times for each list size. So here are my results on my machine. Yours might be different, right? Most likely it will be different. Even if I run this program on my machine again, I may get a different result. So with a list size of 10,000, sequential search took this much time, and binary search took much less time. You can see that here. With a list size of 11,000, I have sequential search taking this much time, binary search taking this much time. Actually, the time decreased for sequential search, but that is an experimental error because there may be other few things going on in the machine that I cannot control. And you can see that the execution times will generally increase for sequential search and binary search, but the increase is not very rapid for binary search. But for sequential search, it is linear. It is directly proportional to the list size. So you can see how it goes, right? So you need to try this out a couple of times to get a feel for what the program is doing. After that, you need to try the two search algorithms for very small lists, like 5 elements to 10 elements. And then you need to try it for very large lists, like 100,000 to 200,000. Okay. And then answer some questions in the D2L quiz, which I will open up a little later. Now, let me show you what the two searches are like before I show you the Python program. Give me a second, I need to find the right window from here. I have a large number of windows open. It should be this one. Right, yeah. Here is an example of sequential search. In sequential search, you put the elements in a list which you studied this week from the videos and PowerPoint and the book. So I have a bunch of elements and they are in the cells indexed from 0 through 7 in this example. If you're looking for 17, you start from the left end and then you compare each element until you hit 17. And that is at index 3. If you're looking for 26, you have to go all the way here to the end. If you're looking for 16, you get it right from the start. So your search may take 1 comparison, 2 comparisons, 3 comparisons, etc., all the way through 8 comparisons. So the average time for sequential search is about n over 2, where n is the number of elements. And here is the algorithm for sequential search. This is what you need to implement in the program. I will show you the program too. And binary search, you need to organize the elements in a list in increasing order, or decreasing order also would work, but it has to be in sorted order. So what you do is basically find a middle element. I'm saying a middle element because there could be more than one index that could be qualifying as the middle element. So 3 or 4 could be thought of as the middle element here because you have an even number of elements. And you compare your target against that. And if it is not a match, you split the list. You either go to the top half or the bottom half. And then you go to the middle element and keep looking. So this approach is much faster for large lists because the list size halves at each stage. So very soon, in fact, after a logarithm of the number of elements in the list, you will be down to 1 element. So even if you have 1 million elements, in about 20, 21 comparisons, you will be done with your search. Even if it is 1 billion, it is going to be like 30 comparisons. With 1 trillion, it doesn't increase much, maybe 40 comparisons. So it only increases by a small amount, even if you increase this list size by very large values, right? So this is a very efficient approach, but it is a little more complicated and you have to arrange the elements in increasing. So it is not really worth for very small list sizes. The complexity is not worth it, and it is not going to give you much better running time for very small lists. But as the list size increases, this shows its power. Okay, so that is the 2 algorithms. You have read this, so I'm not going into depth. And finally, let me show you the Python program that you need to modify. So here is the Python program. It has a few functions. One is to do sequential search. A second one is to do binary search. And the third one sets up the experiment. So let's first get to the place where you need to do some modifications. The sequential search function has a few lines of code that sets up the search of my list. My list is the list that needs to be searched. And this is the number of trials, number of iterations that you need to do for this list. You don't have to know a great deal about this. this simply sets up a target value that you need to search. So you need to know what this variable is. This target is the variable that contains a value that you are searching for in my list. So my list is the list, and its length is in this variable length. So if my list is say 1000, if it has 1000 elements, length would be 1000. And here I am setting up a certain target. Maybe it is a value in this list, or maybe it is not a value in this list. It doesn't really matter to you. What you need to know is that target is the variable that contains the value you are looking for in my list. So here is where you need to do some modifications. 3 lines: set index to 0, while index is less than length and cell at index is not equal to target, increment index. So this just 3 lines of code. You are not allowed to use break. We haven't covered that in this class. Do not use a for loop. Okay, actually this is not for loop. This is a typo. You must use a while loop, all right? Because you cannot use a for loop. This is a typo. I don't know why I wrote that. So let me emphasize again, it should be a while loop, not a for loop. And here you need to write a condition while index is less than length and cell at index is not equal to target. And here is the only statement that is inside the loop, which is incrementing index. What I am doing, if you are curious, is I'm finding the time before I start the search, and after I complete the search these many times. So maybe number of trials is 100 or 1000, whatever. After so many searches, what is the time? So what is the time difference? How much time did I take to do 1000 or 10,000 or whatever number of trials I'm doing here? And this returns the difference in time divided by the number of trials. So the time for one search. And here is the corresponding code for binary search. Much of the code is the same here. Up to here, it is the same code as in sequential search. And here also the code is the same as in sequential search. Here I have binary search implemented. You don't have to know anything about this function. It is, you can just, as far as you are concerned, you can just ignore this completely. You can also ignore this completely. Everything is coded. What this does is it asks for the starting list size, ending list size, the increment, and number of iterations for sequential search and for binary search. And it sets up the lists and everything that you need to have, including the displays. Everything is done. It calls the sequential search function, the binary search function. So don't touch the code anywhere except these 3 lines where you need to implement sequential search as part of this for loop. So the sequential search should be within the for loop. Okay, so everything has to be aligned with the if and the else. Of course, except increment index, which will be part of the while loop. Let me emphasize, it is not a for loop. The program that you download will say a for loop. Let me emphasize again, it is not a for loop. You must use a while loop and do not use break. Okay, so that is the program that you need to modify. As you are working on this, you should open the D2L quiz called Lab 12, and either while conducting the experiments or after you finish the experiments, you need to answer all the questions in that quiz. There are not that many questions, maybe about 6 multiple choice questions plus 3 questions where you need to copy some stuff. You need to copy your 3 lines that you code here into one of the questions. There is a box where you need to copy. Then you need to copy the output that you get for very small lists and very large lists. There is no Dropbox. Okay. So do you have any questions before we start the class exercise? Anybody? Okay, then I will close this and I'll stop the sharing. Let me stop recording.